so sorry for the delay. So let's get going. All right, so now we're going to be doing section 10.3, which is matrices and systems of linear equations. So we're going to be doing what we did last section, just we're going to do it in slightly abbreviated form. It's not that much abbreviated, but it's just easier to do. So we're going to start with the definition of a matrix. A matrix is an M by N rectangular array of numbers with M rows and N columns, so it's row by column. Each entry we call the ij entry, and so this would be in like this one. It's the A32 is the third row, second column. Here be there's a little typo here. This one would be the second row, third column, and so forth. And so this is what we define to be a matrix. Now, definition of an augmented matrix. So if we take a linear system here of the coefficient on x plus the coefficient of y equals to b, 1, and the coefficient of x and the coefficient of y equal to b2, we can write that as an augmented matrix in the following form, where we have a1, a2, where here things in the first column are x, things in the second column are y, and things in the third column are constants or b, right? So since this is linear, it's always just going to be a single x and a single y. And so we're going to be doing this to solve systems. But the first thing to do is, how do we encode all of this? And so let me just kind of show you how this is done. I'm just going to make a matrix. For those who haven't worked with matrices before, it's a good place to start, as any. I'm just going to write down the coefficients. So for the x, it's 1. And then for y, it's -2. Here it'd be 3. And then I like to do a little dotted line. This isn't necessary, and I probably won't use it all the time, but 7. Here I have 4, 2, -1, and 42. Here I have 3, 2, -5, and 5. Okay. So basically, instead of writing x plus y plus z and all this other stuff, we're just writing the coefficients, because we always write it in this format. And so even here, so let's do this. So when I say write an augmented matrix, computer, I just restarted. Why are you being so crunchy? Line here. I'll actually do a little dotted line. 2. So here 24, and 1, and 7, and then we have 5, -2, and 2. And so here, if we have 3 equations and 2 unknowns, we can write it this way. And we'll just go ahead and just do this out. So all I'm doing here to make these augmented matrices, I'm reading the coefficients. So here it's 3, -2, 1, and 2. Here it's 0. And so if there's nothing here, go ahead and put in a 0 as a placeholder. 2, -1, 1, and then 0, 0, 5, and 15. And so it doesn't matter where the 0's at, but please make sure you always have your x in the x-coordinate. So here we have 0 x's, 1 y, 3 z's, and our constant is 1. If this was written as y plus 3z equal to 1, x minus 7z equal to 3, and 33 x plus 42 y equal to 125, there might be a tendency just to write the first coefficient here would be 1, 1, 1, 33, and then 3, -7, 42. But notice here, you need to make sure your x's are where you have your x in the first column, the y's in the second column, the z's in the third column, since we have 3 different variables here. So even if it looks like this, kind of think of it like this in your head. And that's why I wrote the problem with this spacing. Because it'd be 1x, 0, y, and minus 7 on the z equal to 3. And then here I'll have 33, 42, 0, and 125. So one thing when you write it in an augmented matrix, make sure that each column represents a single variable, okay? And so in this case, it's x, y, and z, and then this last column is your constant column, or which we're using as b. So if you have 5 variables, a matrix of that, so make sure it's in 5. And even if these equations don't always contain each of the variables, make sure to put the variables where they belong, okay, in the matrix. That's very, very important. All right. All right, I'll take a quick sip as you write that down, and then I'm going to save it and export it just because it's being crunchy. Yep, go ahead and export that out. Yep, that way maybe it'll be a little less crunchy. All right, so let's zoom on in here. So so here we can perform row operations to just define the solution system, same as before. And so we're going to interchange one row for another. So interchanging rows is the same thing as interchanging rows, the same thing as interchanging equation, multiplying one row by a non-zero constant, same thing as multiplying an equation by a non-zero constant, and adding a non-zero multiple of one row to another is the same thing as adding the two equations. Okay. So these are the same goals and operations used to follow the system. So we're going to try to get rid of this term, and this term, right, in that order. And so we're going to do that. But first, we're going to put it into an augmented matrix. And so let me kind of show you. We're going to do the same thing we did before, but I'm going to show you how with an augmented matrix, it just gets easier to crunch the numbers. It just does. So here we go. A little dotted line right here. All right, so this is 1, -1, 3, 4, and then we'll have 1, 2, -2, 10, and then we'll have 3, more like a 3, -1, 5, and 14. Okay, so here I'm just encapsulating, encoding into this augmented matrix, just the values here. All right, so the first thing we want to do is make this a 0, right? That's our first step. Get rid of this term, right? Or make this a 0. So to do that, I'm going to add -1 of the first row of this top row to the second row. And just because this is the first time we're doing augmented matrix, I won't do both at the same time. Could you? Yeah, you could technically just give -3 here and do it both at the same time, but we won't do that. We'll do it step by step since this is our first time using the matrices. All right, so I have not changed my first row, and I have not changed my third row. So I'm just going to copy those down. Here, I've added -1 of this row to this row. And that makes doing this math a lot easier. Because here, it's the same math, but you have other characters and other stuff for your brain to process. Here, it's a lot easier for your brain to process what's going on. So I want -1 of this row added to this row. That gives me 0. Negative of this would give me 1, added to this gives me a 3. Negative of this gives me -3, added to this gives me -5. Negative of this is -4, added to this is 6. Okay, so we're just taking a negative of this row, adding it to this row. So the next thing we want to do here is get rid of this term. So we'll just put in, we want to do -3. So let's go ahead and do that. So the first row is the same. We didn't alter that at all. The second row is the same. We didn't alter that at all. The third row here, so -3 times this added to this is 0. By design, right? That's literally why we chose the -3. Let's make this 0. -3 of this is +3 plus the 1 is a 2. Negative 3 of this is minus 9, plus the 5 is minus 4. Negative 3 of 4 is negative 12. Add to 14 gives us 2. Okay. All right. Now I'm going to do something that I know that I want to do. And so here, there's no real clean way to get rid of this, right? There's just not, at least not right now. But here, notice everything's divisible by 2. So I'm just going to interchange these rows. And this is the first time I think we've done interchanging just to make our lives easier. Because it's easier, it'll be easier if I interchange this, life will get easier. And I'll explain why I'm doing this in greater detail on the next one. But for now, I just want you to kind of go with it. So 1, negative 1, 3, 4, 0, 2, minus 4, 2, 0, 3, negative 5, and 6. So once I'm here, I can make this a 1. And this is easy to make into a 1. Why? I just multiply this row by half, right? So if I multiply that row by half, I'll have 1, negative 1, 3, 0, 1. Let's minus 2. Hi, I didn't finish this tonight. 4, 1, 0, 3, negative 5, 6. Now it's actually quite easy to get rid of this row. Here I'm just going to do minus 3 down, right? I'm going to write that up here though. All right, so here, the first 2 rows are the same, so we'll copy that down. 1, negative 1, 3, 4, 0, 1, minus 2, 1, 0. Then here we'll go ahead and do that. So negative 3 added to this is 3, so 3 is 0 by design, right? That's why I switched these rows. It's like, well, out of these 2, this one's easier to move up. And then here, negative 3 of this would be positive 6. Added to this would be a 1. And then here, negative 3 would be negative 3. Added to this would be a 3. Okay. All right, so from here you have 2 options. The first option is you can just write down what these equations mean. This means x minus y plus z equals to 4. Here I have y minus 2z equal to 1. And then here I have z equal to 3. From what we taught you last time, you can just reverse substitute in and get a solution. That's perfectly fine. But another way of doing this is you can put this into, you can follow the following procedures. Once you have it to here, I'm going to temporarily mark these off, so don't mark these off in your favor, but I'm going to remove these ones. And how can I do that? Because I have zeros here, I can remove these 2 entries, make these 0, and then once this is 0, I can remove this one. So you kind of do, so it's kind of done in reverse. And so when you first do it, you get rid of this term, and then this term. And then when you go backwards, you get rid of this term, and then this term. That way you have just ones on the diagonal. And I'll show you why you want to do that. Okay. Notice here that every step we did here, you could have just done with the equations themselves. But this way is just simpler and easier to run with. And this is what your computer will do. It will actually make these matrices and do it. There's actually a lot of really fancy math to do this. All right, so here, if I want to get rid of this term and this term, I'm going to do, and this one I'll go ahead and do 2 at once. I'll do 2 times this row added to this row, and then negative 3 of this row added to this row. So here this will be 1, negative 1. This is really easy. This is 0, and then negative 3 of this would be minus 9. So this becomes minus 5. And then here we have 0, 1. I'm adding 2 times of this row, so that's 0 by design, and this becomes 7. And then I have 0, 0, 1, and 3. And then the last thing I want to do is get rid of this term. So I just need to add one of this row to that row. And then what am I left with? Here I'm left with 1, 0, 0, 2, 0, 1, 0, 7, 0, 0, 1. All right, now if I translate this over, this means x is equal to 2, y is equal to 7, z is equal to 3. And once again, notice if I plug that in here, I'd get the same answer. So here, I'd get y minus 6 equals 1. Move that over, that's a 7, right? And then here I'll have y minus 7, or x minus 7 plus 3. So that's minus, hold on, my brain a little quieter. Oh, this should be a 3 here. I'm like, this isn't working. This would be x minus 7 plus 3 times 3. Now this is 3 here. I missed it over here. It's 9. So I have plus 2. And so in order for that to be that, we get x equal to 2. So either way, it works. What was the question? What was the question I missed? So why didn't the second?
So down in on the second version of the sequence, whatever I forgot, my bad. But down on the second row, why is the y spot in the second row 3 and not 1? Because didn't you add -1 to it? So you added -1 to 2 and it became 3. Is there a reason, or?
-1. Oh, minus a -1 to 1. So that becomes +1.
Oh, okay. Okay, my bad.
Yeah. It's, trust me, that's very, very easy to miss very simple things on this.
Yeah, signs are always what gets me. That's like
Oh,
I'll
trust
have
me.
the entire thing perfect, then I'll forget to change something to a negative, then I'll ruin it.
Let me explain the terror of doing these by hand. I'm working with a set of notes with it all done out, right? And there's a reason for that. Because if I make, not algebra, arithmetic calculations did I do? Well, I'm doing at least 4 per line, right? So that's 4, 8, 12. So 4 times 1, 2, 3, 4, 5, 6, 7. So I'm doing 28 arithmetic calculations in my head. Chances are you mess one up, right? So if something goes wrong, double check. This one you always want to check. And the easiest way to check is just plug it into some of these. So we already checked the top one because we did that one. Let's check this one. So this would be 2 plus 14. So that's 16 minus 6 is 10. Yeah, so that works out. So kind of check these. It's just a lot of arithmetic. That's all there is to it. It's just a lot of arithmetic. All right, so let's go to the next page. All right, so let me kind of explain a couple things and I'll show you what we're trying to do and where we're going. All right, so we call a matrix in row echelon form if it has the following conditions. That means the first non-zero number in a row is 1. That we call this a leading entry. The leading entry is to the right of the leading entry of the one below it, and all 0 rows are below non-zero rows. We call that row echelon form. And so let me show you kind of an example of this. This here is in row echelon form, right here. This is in row echelon form. We abbreviate that REF because here is a leading entry and it's a 1, right? And then the next leading entry, which is the first non-zero, next leading entry here is to the right of the row above it, so it's over here. Notice it could have been on the third column as well. And then here, there's another one. this is an example of it being in row echelon form. Okay. Then here, the reduced row echelon form, which is abbreviated RREF, has the following conditions: is that every row, every number above and below a leading entry is 0. And so what we did is we made this. So this is in, so if this is an REF, this is an RREF, or a reduced row echelon form. So here we have leading entries. It's 0 above and below it. Okay. These are just names. You use these more when you work with system equations more and work with this more. This is just kind of an introduction and actually get you through the bulk of it, right? But you can get real in depth with this stuff. I'll go ahead and just leave that. Okay. And so in order to do this, there's a very algorithmic way of doing this. And this is what the computer does dogmatically. This is what a computer does. It's called the Gauss-Jordan elimination algorithm. It has a name. Basically, you're going to give a matrix, and I'm going to use a box just to represent anything, right? So these could be any numbers whatsoever. You're going to try to get a 1 in the first entry, and then once you get the 1 there, you're going to use this 1, and you're just going to multiply by negative of whatever this coefficient is. And so in this case, it was minus the 1 and then minus the 3, right? And just add those up. All right. And then you're going to get zeros here. So like I said, eliminate this one and then this one. Okay. Once you do that, the algorithm asks you to put a 1 here. It's not always necessary, but it is a good idea to do that. And so in order to do that one, and I did the algorithm here. I did the algorithm. I was like, well, I want a 1 here now. Well, if I divide this by 3, I get fractions. Now I don't want to do with fractions as I'm doing arithmetic, right? You just don't, because the second you have fractions, you're going to have fractions for a while. So I swapped the rows. It's like, well, this divides evenly by 2. So I switched the rows and then divided by 2 to get the 1 here. Okay. So I did the algorithm. I put a 0 here, put a 0 here. Then I was like, okay, let's get a 1 here. And so, okay, I got the 1 here. So I moved stuff to get a 1 here. Then I got a 0 here. So the next thing after that, you get a 0 here. And once you get a 0 here, you want to convert this into a 1. And then you go ahead and once I have that 1, luckily when we got the 0 here, we also got the 1 at the same time. So it just worked out as happy happenstance. Then you go back, put zeros here, and then put zeros here. If you do it outside of this order, say I got a 0 here first, right? And then I try to get zeros here. Well, when you add whatever this row is to this one to get this to be 0, you'll destroy this 0. Because now it's something not. So by doing it in this order, it makes sure you don't waste your time, because you can easily do stuff. If you're not following the algorithm, that'd be counterproductive. I mean, it might be 100% mathematically correct, but it's counterproductive. So let's do this algorithm one more time. Came late. So let's do this algorithm one more time. All right, so let's do. All right, so here I'm going to leave this up. I can see the algorithm, and we're going to see if I can. All right, so let's do this. And so here, the first step of the algorithm is I want this to be a 1, right? So let's go ahead and just do that. So the first thing, write it all out. So I would write it as an augmented matrix as your first step, just to make sure you don't miss the negative sign. And if we were doing this in person, this would be where I would have you guys run through it. But since we started a little bit late because of computer issues and other stuff, I'll just crunch through it real fast. Well, not real fast, but So here, I'm going to just multiply this row by a fourth. You don't always have to say that. It's perfectly normal. Most people know what you're saying if it's like, I'm going to divide by 4, right? Because that's what you're doing, really. You divide by 4. And why? Because I want a 1 up top, right? Because once I get a 1 up top, it makes it easier to get rid of this. If I leave this as a 4, it's harder to get rid of the 3 and the 2. So I'm going to get a 1 up top. And since this cleanly divides by 4, I'm going to choose this row. All right, so that's going to give me 1. Oops, I need to write it all down. So 1, 2, minus 1, 1, 3, 8, 5, minus 11, minus 2, 1, 12, minus 17. Okay. And so here, we've achieved this. So here, we started here, we now achieved this. So we're good to go there. The next one we want to do is this step. So in order to do this step, we're going to take I'm going to take this row, multiply by -3, add to this. So basically whatever's here, just multiply a negative 3 by that, since this is guaranteed to be a 1. And so here's the 2, so I just want to multiply that by 2. Okay. And that should give us 0. So here we'll just, the first row is the same. We did nothing to it. So here we have -3. So 3 plus a -3 is 0. 8 plus -6 is 2. 5 plus 3 will give me 8. 11 minus 3 gives me -14. Here we'll have 2 of this, so that'll be 0 by design. So 4 plus 1 gives us 5. -2 plus 12 gives us 10. And then we'll have um, -17 plus 2 gives me -15. Okay. All right. So here I've achieved this goal. Right? So I've achieved this goal right here. I'm like, okay. So my next goal is to get a 0 here. Or no, I've achieved this goal. So this goal is achieved. So my next goal is this one. Get the 1 there. Okay. I'm going to do that. Well, this easily divides by 2. So let's go ahead and divide that by 2. Let's put that up here. So I have 1, 2, minus 1, 1, 0, 2, 8, minus 14. Oh, no. I'm copying that down. I should have done math. It should be 1, 4, minus 7. And then here, this is the same. 0, 5, 10, minus 15. Now, I could divide this row by 3, but it may or may not be productive. Or by not 3, 5. All right, so now I've achieved this goal. My next goal is a 0 here. So how I'm going to do that? Just minus 5 of that down to here. Let's go ahead and do that. 1, 2, -1, 1. Now I'm going to lose my voice. Not only going to have computer problems, I'm going to have biological problems. And just slowly fall apart on you guys. So -5 plus 5 would be 0. -5 times 4 is -20, plus 10 would be -10. -5 times 7 gives positive 35, divided by minus plus the -15 would be positive 20. All right, so I achieved this goal, right? Now I have a 0 here. Next goal, make this a 1. Well, here we'll divide by -10. So I have 1, 2, -1, 1, 0, 1, 4, minus 7, 0, 0, 1, -2. All right, so I have achieved this goal. My next goal, this one. So just follow this pattern, right? I try to make it as your book writes it all out. I'm like, oh my goodness, no one's going to understand if you write it out, and it's just a disaster. Most people like cute little visual, guides. And isn't this what you guys mostly do when you don't understand math anyways? You just look at the old problem and kind of follow the steps that you did last time. Well, here I made it kind of like a blank template for you just to filter in. because I think that's the easiest way to understand it. So here I want to get zeros here and here. So here I'm going to add -4 of this and then just 1 of this. I'm just going to add this row to this row. Okay. So let's do that. So if I add just this row to this row, I'll have 1, 2, 0, and then -1. And then here this would be 0, 1. If I add -4, so that'd be -4, that'd be +8, so 0, 1. This is 0, 0, 1, -2. Notice here, if you get to this point, you can just reverse backwards substitute. And some people like to leave and do backwards substitution. I always like to carry it to the end. All right, so the last thing we need to do, the last thing we need to do is get a 0 here. It's our last step. So we'll just do -2 of this. We'll have our final one, which will be 1, 0, 0, -3, 0, 1, 0, 1, 0, 0, -3, 1, -2. That's our answer here. All right, so let me show you how to do this in Wolfram Alpha. The only thing I feel bad about this class is I've shown you how to do everything in Wolfram Alpha. And I don't think that's a bad thing. I just don't think everyone does it by hand first, because once I show you how to do it in the computer, why do it by hand, right? It is good to do things by hand, and it is good to try it that way. All right. So let me open Wolfram Alpha up. All right. So let me show you how to type this in. At least I'll show you how to do one of them. All right. So you hit the double bracket, and then you're going to type in your matrix as following. So bracket, bracket, 4, 8, -4, 4. Okay, so that'll be your first row. And then you hit a comma. So it's going to be bracket, and then you put inside brackets the first row. And then the next bracket would be the second row, which in our case is 3, 8, 5, 11. Close bracket. Then we'll do our last row, which will be -2, comma 1, comma 12, comma 17. Close that all up. So this will input into Wolfram Alpha. Okay. Now if we type in REF, that'll put it into row echelon form. Give it a second. You'll think about it. It's still thinking about it. It is not doing what I told it to do. Fine. Here, if you type in RREF, this should work. It should put it in reduced row echelon form. Woo! Oh. Hi. This should be a -17. I'm like, that's not right. Please check your matrix. Please check your matrices. Oh, that looks a lot better. So once again, we did it by hand correctly. We typed it in the computer wrong. And that's why I say do both. That way you know you did it right for this class. Now, in actuality, you're 90% of the time just going to use the computer, right? That's what you're going to do anyway. But this is how you just type it in, all right? And so you're going to be typing in a couple matrices from today's stuff. So this is reduced row echelon form. Just pops it out this way for you. Okay? You can type in any matrix this way, and I'll show you how to type in other matrices later. But let's go ahead and save this out. Or no, I'll save it out later. Well, let's just do this last thing real quick. All right, so here, go ahead and here. All right. Okay, so let's do. So so you have the same thing. So exactly each column will have a leading entry. So Let me explain. Let me just kind of give you an example and explain it. Here's kind of words for it, but here. So if it has exactly one solution, every column with a leading entry, every column will have a leading entry. So every one of these columns will have a leading entry, and they correspond to some number. Okay, and I'll just put little stars to represent some number. Right? If there's no solution, you're going to have at least one of the rows will translate into 0 equals a constant. And let me kind of explain that. So if I have 0, 0, 0 star, 0, 0, or 1, 0 star, and then 0, 0, 0 star. And I'll go ahead and put in the little dotted line again. If you have this, that means no solution. That means 0 is equal to a constant. And we'll remember from last time, or the last two sections, that means it's inconsistent. Inconsistent means it doesn't have an answer, so no solution. So consistent matrices have answers. So this is consistent. I'll write that there. This should say consistent. I don't know if that says consistent. I think that says inconstant. It should say inconsistent. All right, so we're not going to rely on my spelling today. Should never rely on that. So a system's called consistent if it has a solution. So this is consistent, this is consistent, this is inconsistent. A little spell check on this. Is it SP? Is that the little symbol you do for spelling error when you do editing? I don't remember. Anyways, now let's get into infinitely many solutions. So here, if we have infinitely many solutions, we'll have this. Something that looks like this. And actually, let me do two. Let me do two different ones of these. All right, so both of these are representation of infinite solutions. So notice this is in reduced row echelon form in the sense that there is no leading term for this section. So y, here we just set y equal to t. Z is equal to whatever this is these, and then x is going to be equal to, in this case, x is equal to whatever this variable is. In this case, since you never get rid of this entry, you just plug in t here and then solve for it. Okay, so I'll show you how to do this. I'll show you how to do this and we'll end this section. The next section is not as long as this one, so I feel good for time. Let me show you how to do at least one of these. All right, so let's do this. So what are we going to do here? We're going to do this algorithm, and we're just going to go ahead. So the first thing we do, we write it in, make an Augmented Matrix out of it. Notice here I don't have any y, so I'm going to plug in a 0 here. This was negative, sorry, 7, and then 5, and then 1, 1, minus 10, and 4. All right, so the first thing I want to do is get a 1 up top. Well, I could divide this by -3 and get a mess, right? Or I could just move the entry that has a 1 up top. So according to a little algorithm, we're just going to swap what row these are. There's no reason not to do that. Okay, so we're just going to swap those rows. Next thing we want to do is get zeros here. Remember our little algorithm. So we start with something. We want a 1 up top. How do we do that? We just switch rows. That's what we did in this case. Now I want to get zeros down here. So how am I going to do that? I'm just going to add one of this row to this row, and then one of the top row, or 3 of the top row to the bottom row. That'll create the zeros. So let's go ahead and do that. So here I have 1, 1, negative 10, 4. If I run through this, it'd be 0, 1, minus 3, 1, 0, negative 2, 6, negative 2. All right. I already have a 1 here, right? That 1 is achieved. So I just want to put a 0 here. How are we going to do that? I'm just going to add 2 of this row to that row. All right, so let's do that. So here I'll have 1, 1, minus 10, 4, 0, 1, negative 3, 1. And then if I add 2 of this row, notice this is 0, this is 0, this is 0. So I get a whole 0 row here. Okay. What do I do now? Well, I continue working, right? But now I can just, the only thing I can do here to simplify is I can get rid of the y here by adding 1 of this row to this row. So here I'll have 1 minus 13. Put a negative 1 here so you guys know what I'm doing. Oh, that's not minus 13, is it? That becomes minus 7, because I'll add. And this becomes 3, 0, 1, minus 3, 1, 0, 0, 0. So what does this translate to? So this has infinite many solutions. And so notice in this case, I have no leading entry for z. Z has no leading entry. So I'm just going to set that equal to 2. I'm going to rewrite what these equations mean. This means x minus 7t. We know what z is, so I'll go ahead and write in the t. Is equal to 3. Guys, did I make a mistake? Have I made a mistake? The answer is yes, but you guys don't know it because I've been just checking answers. This should have been a negative 4. Now you think, oh, I messed up everything. No, because I've been cheating on this one. I'm not gonna lie, I've been cheating because I've already done it. I just forgot the negative 4. And so I've just been reading these entries and just copying those from the page. It is correct as written. Here I solved it differently. But this should not be negative 4. This should be, if this is negative 4, this doesn't become a 3. This becomes minus 5, which gets me to my correct answer. Sorry about that. It's so easy to drop a negative sign. So all you have to do is add negatives in. All the other entries are correct because I already pre-calculated this. This says y minus 3t is equal to 1. And then here we're saying that z is equal to t. That's what we defined it to be. All right, so now we can rewrite this as x equals 2 minus 5 plus 7t. Y is equal to 1 plus 3t. We'll have z is equal to t. And so our solution here is negative 5 plus 7t, 1 plus 3t, and then t. Okay. All right, so that's the end of this section. So the difference between 10.2 and 10.3 is one we do it in matrix form, the other one we just do it in without using the matrices. And the matrix just makes this easier.